Okay, so page 7, packet or the handout that you got is just for reference. I just want to kind of give you a visual connection with what an inverse function of the trig looks like, but we don't have to draw it. I just want to just have you make that connection. Okay. So before I get into trig inverse, let me just talk about inverse functions in general. So let's talk about a function that we are familiar with, right? Y equals x squared. We know what that is. That's just a parabola. So if you look at y equals x squared, let me just identify some easy order pairs, right? So 0, 0, if I plug in 1, I get a 1. If I plug in -1, I get 1. 2, 4, -2, 4. Parabola, right? That's an easy function. We're very familiar with that graph. Now, the inverse of it is where we flip-flop all the x and y values. Okay, so the inverse function is actually x equals y squared. Because if I replace the x with y and y with x and solve for y, if I solve for x, I get x equals y squared. So that means all the order pairs should be flip-flop. Okay? So 0, 0 will stay, 1, 1 will stay, -1, 1 becomes what? 1, -1. 2, 4 becomes 4, 2. -2, 4 becomes 4, -2. So this is what the graph looks like. So inverse function, it basically looks like a folded graph along the horizontal line. So it's kind of, in essence, it's almost like you're taking the graph and you're kind of flipping it sideways. Okay. And what I want to talk about is is this inverse function, or sorry, is this inverse a function? Not a function. Why is it? Yeah, it doesn't pass the what? Vertical line test. Okay. So the way that we can tell whether a function's inverse will be a function is look to see if the original function passes the horizontal line test. Okay. So in this case, if a graph doesn't pass the horizontal line test, that means that its inverse is not going to pass the vertical line test. Does that make sense? Okay.
What's the vertical line test?
So vertical line test is saying, does the graph cross more than one point on the curve? It does, right? So that means it's not a function. Okay, so in order to be a function, the graph can only, any vertical line that you draw, you can only touch one point. So that's what a horizontal line test. Horizontal line test is determining if its inverse will remain a function. So this parabola doesn't pass the horizontal line test, which means that its inverse will not pass the vertical. What about this graph here? If I have this cubic function, is this going to pass the horizontal line test? Yes. Yes. Which means that its inverse will be, yeah, will pass the vertical line test. Okay, so that's what a horizontal line test does. It just tells you information about the inverse. Okay, so let me go ahead and read some of these notes here. Okay, so recall that for a graph to be considered a function, it must pass the vertical line test. Right? So obviously this parabola is a function that passes the vertical line test. For a function to have an inverse, it must pass the horizontal line test, meaning that if you switch the x and y's, the inverse would pass the vertical line test, which in this case, this would not pass the vertical line test. Okay. Now, recall properties of inverse function. X and y will switch, so the domain and range will switch. Okay. And your graph is always going to be reflected over the line y equals x. So here, that's what a visual representation would look like between a function and its inverse. If you were to fold the graph along that diagonal line, your graph will overlap. So we have the sine graph here. Okay. This is the sine graph. Okay. Now this is a function, right? It passes the vertical line test. But is this sine graph, does it pass the horizontal line test? It doesn't, right? So that means that its inverse is not a function. Okay. But what if we could do this? What if we could just restrict the domain and we only show a portion of the sine graph. Okay. Would this portion pass the horizontal line test?
Yes.
Yes, which means that its inverse would be a function. Yeah. Yeah. So I didn't print this one out here, but I want to kind of show you real quick. This is what an inverse would look like for sine, right? And we can obviously tell that, okay, this is definitely not a function. But if we were to restrict the domain, meaning that we were to just show a portion of it, then this part would pass the vertical line test, right? Now, if we extend it any further, then it'll start backtracking and it'll begin failing the vertical line test. Okay. So that's what we need to do in order to make an inverse trig function a function, is if we were to say, okay, we have a starting and ending point, we're restricting it so that we can force it into a function. So if we restrict the domain of sine from negative pi over 2 to pi over 2, so notice that negative pi over 2 to pi over 2, okay, we're basically looking at the region closest to the x-axis while maintaining a function, but we also want all the y values represented. Okay, so in a sense, we're looking at the fourth and first quadrant. Okay, the restricted portion would pass the horizontal line test, so therefore the inverse is a function. Okay, we refer to these restricted values as principal values. So think of principal values as calculator values. Okay, so if you were to enter into your calculator would give these in return. And principal values are values that are closest to the x-axis. Or sorry, closest to the origin. Okay. Now, the notation for principal values are these uppercase letters. So capital S, capital A, capital C. Okay, so anytime you see uppercase sine, uppercase arc cosine, that indicates that that we're talking about principal values. We're talking about these specific values with these restricted domain. Okay. Okay, so here's how the domain restrictions look with respect to the unit circle. Okay, let's talk about each of the quadrants. Okay, so for sine, first quadrant is what? Positive or negative? Positive. Second quadrant is positive. Third quadrant is negative, and the fourth quadrant is negative. Okay. Now, if we're talking about principal values, we're not going to look at the second and third quadrant because those are too far away from the origin and they are not part of our principal value domain. So if we're talking about, if I ask you for arc sine with the uppercase A, then you're only going to provide values in this region between negative pi over 2 and pi over 2 in the fourth quadrant and the first quadrant. Okay. For inverse cosine, okay, for inverse cosine, cosine is positive, negative, negative, positive. We don't do fourth and first quadrant because then we wouldn't be able to represent all the values that we want, all the possible y values. So we look at the first and second quadrant. Now for our tangent, or tangent in general, tangent is positive, negative, positive, negative. We don't do first and second quadrant. The reason why is because if we look at the first and second quadrant, the inverse function would not remain a function. It would fail the vertical line test. So it is only going to remain a function in this restricted region closest to the x-axis between negative pi over 2 and pi over 2. Yeah, the reason why is, let me show you with the second handout that you guys got. Okay, so that second page here, this is the sine graph, right? Sorry, tangent graph, tangent graph. So for the tangent graph, we only want to restrict the domain from negative pi over 2 to pi over 2, because after this point, the graph will no longer stay a function. So we have these restrictions in place so that we can be closest to the x-axis. We can restrict between the fourth and first quadrant, because otherwise after that, it will no longer be a function. Okay. Yeah, that feels like a lot, but I think the main idea that you want to keep in mind is that your sine and tangents is fourth and first quadrant, and then your cosine is the only one that's going to be the first and second quadrant. Because if it's other quadrants, it's either too far or it doesn't remain a function. So we're restricting it so that all the positive and negative values are represented, but it's closest to the x-axis, to the origin, and it can remain a function. So all those restrictions play a role as to where the quadrants are going to be used.
The cosine or tangent can only be in the first.
Yeah, first and fourth quadrant. So if you look at the tangent graph, right? You see how the tangent graph is going from negative pi over 2 to 0, and then from 0 to pi over 2. So negative pi over 2 to 0, that's essentially the fourth quadrant. Because negative pi over 2 is, right, if I subtract, I'm going down to that fourth quadrant. Yeah. But we have to think about fourth quadrant a little differently, because we're going to be to the left of the origin, right? And so if we're to the left of the origin, we're not going to be waiting until all the way to 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. The way we represent fourth quadrant with principal values is we have to use these negative values, okay? So if you guys can kind of add that to the bottom of the page here, and just as a reminder that if you're thinking about fourth quadrant and you're thinking about 11 pi over 6, treat it like negative pi over 6. Okay. Instead of saying 7 pi over 4, you're going to say negative pi over 4. Okay. Instead of 5 pi over 3, you're going to say negative pi over 3. Instead of saying 3 pi over 2, you're going to say negative pi over 2. Okay. Now, you're only going to be doing this for sine and tangent. Okay. For cosine, you're just going to go from 0 to pi. But for sine and tangent, if you see something that's a negative value, you have to go to these, or you have to go to the fourth quadrant. Okay, I know it feels very abstract right now, but I think as soon as we get to our unit circle, we'll just be able to nail this down. Okay, so for example 1, it says find arc sine of -1/2. That's an uppercase A. So another way of thinking of saying arc sine of -1/2, another way of saying it is this. Sine of what angle theta will give me -1/2. So for what radian measure is sine going to be -1/2? Okay, sine is negative in which quadrant? Second and fourth, but we're talking about principal values, so we have to use which quadrant? Fourth quadrant. Okay, so fourth quadrant, where is sine going to be -1/2? 11 pi over 6, but we have to adjust it, right? Instead of saying 11 pi over 6, we're going to say negative pi over 6 because of our restriction of our domain. So theta is equal to negative pi 6. Okay. And the reason that we know to say negative pi over 6 instead of 11 pi over 6 or in the third quadrant, right? Because it's also negative in the third quadrant, or saying 7 pi over 6 is because of this uppercase A. So that uppercase A indicates that, oh, we're talking about restricted principal values. So we're looking at just the value closest to the x-axis. Yes, basically we answered part B there. What angle has sine equals -1/2? Okay, example 2. Find inverse tangent of 0. So in other words, if the inverse feels a little bit weird, or you're not familiar with it, then rewrite it. Rewrite it in a way that feels familiar, right? You can then ask yourself, it means the same thing. It's just written in a way without the inverse. So you can say to yourself, tangent of what angle is equal to 0? Okay. Where is tangent equal to 0? tangent is y over x, right? So tangent of 0 is 0, right? Because 0 is in that restricted domain from negative pi over 2 to pi over 2. Yeah, so we answered A and B just by writing it that way.
Just the 0.
Yeah, because at radian measure 0, my tangent value ratio is 0. I'm sorry?
You look in quadrant 1.
Yeah, for tangent, we only look at first and fourth quadrant. For sine, we only look at first and fourth quadrant. For cosine, we look at the first and second quadrant. Yeah, you will say 0 because tangent is you have to provide your answer between negative pi over 2 and pi over 2. So we're never gonna say like, 2 pi because it doesn't fall inside the interval. We only want the theta value closest to the x-axis between our interval. Okay, so let's look at some of these examples, and then once we get a hang of it, then we'll just do page 9, and then we'll be done. Okay. So arc sine of -1. So you see that uppercase A, you're talking about principal values. You can rewrite it as sine of theta equals -1 to make it more familiar. And then we ask ourselves, where is sine equal to -1? 3 pi over 2, but we got to adjust it, right? Instead of saying 3 pi over 2, we're going to say negative pi over 2. Yeah. So that's just the only adjustment you have to make is, okay, if I'm in the fourth quadrant, I just have to subtract 2 pi from it, basically. You're basically subtracting 2 pi to land in that interval that you need to land in. 3 pi over 2. Well, where is sine equal to -1? Sine is the y value, right? So sine of what angle measure is equal to -1? So sine of 3 pi over 2 is equal to -1, right? Or let me ask you this. What's sine of 3 pi over 2? -1, right? And basically I'm asking, sine of what angle measure is equal to -1, and we're just looking at the unit circle and working backwards, right? So we're trying to find theta, and we found theta is 3 pi over 2. But we have to make an adjustment because of our restriction, so we say negative pi over 2. Okay with that? Okay. So theta is equal to negative pi over 2. Okay, let's do part B. Our cosine of -√2 over 2. So this problem is asking us to find an angle where the cosine value of -√2 over 2. So in other words, if you always want to rewrite your r cosine as cosine, then that's fine. Maybe that makes it more familiar. Okay, so where is cosine equal to -√2 over 2? 3 pi over 4. Cosine, we're okay with the first and second quadrant, right? We're not going to touch the fourth quadrant because cosine is positive in both quadrants, so it's not going to give us everything we need. We want to do the first and second quadrant. So cosine of 3 pi over 4 is equal to -2 over 2. Oh yeah, so cosine's restriction is from 0 to pi.
It doesn't.
That's right. That's right. So cosine is nice. Cosine, you don't have to worry about any changing because first and second quadrant is exactly where they need to be. Only sine and tangent, you got to worry about adjusting it if you're in the fourth quadrant. Okay, so I'll write those here. Sorry, I wrote that -1. It's either inverse cosine or arc sine, but they're interchangeable. So arc sine is in the fourth and first quadrant. Cosine, you're only looking at the first and second quadrant. Arctangent, fourth and first quadrant.
What happens when it's in like a third quadrant?
I'm sorry?
How about when it's in the third quadrant?
Well, we're not going to identify third quadrant because we can find everything that we need within the first three quadrants. And the reason why we don't look at the third quadrant is because it's not part of the restriction for our domain. Because if we look at the third quadrant, then your arc trig function is no longer a function. It will start failing the vertical line test. So if you look at your last page of that handout, your cosine is only going to go from 0 to pi, because if it extends past pi, then it'll start backtracking and it'll start failing the vertical line test.
The arc cosine like restrictions, I just don't understand the arc sine and arc tangent restrictions. Like why it's negative pi over 2, pi over 2.
Right. The reason why is because here is what the sine graph looks like, right? And if I do the inverse, then the inverse is over here, right? So I could flip that, then here's my inverse function. Okay. And you see how my inverse function is going from negative pi over 2 to pi over 2? So negative pi over 2 to 0, that is considered fourth quadrant values. And then we don't go past it, because if we went past it, then it'll start failing vertical line test. Okay, so let's go to our tangent of 1. So in other words, rewrite it. Tangent of theta is equal to 1, whereas tangent equal to 1. At what angle measure?
Pi over 4.
Pi over 4, right? Pi over 4, because y over x is 1, right? Yes.
Is the only difference between like tangent and arctangent that arctangent has limitations?
That's right, has limitation, right? So if you see that capital A, we're restricted to just that region where it'll still remain, where the inverse will still remain a function. Yeah, so we call that principal values. Principal values is we just want the answer that's closest to the origin.
Tangent negative 1, I think we were on.
Yeah, so if it's a good question, right? So what if it was arctangent of negative 1? First and fourth, right? So in other words, tangent of theta, where's theta? So that tangent is equal to negative 1. Good. All right, negative pi over 4. Okay, let's just go down. Let's do D and G, and then we'll do E and H, and then we'll do F and I. Okay. So inverse sine of 0, you see that capital S, capital A. That means we're talking about principal values. Okay, so sine of what angle measure is equal to 0? 0, yeah, so theta is 0.
Sine negative 1 is the same thing as arc sine.
Yes, they are, yeah, so that's why, yeah, that's why you see it twice, so that you're familiar with those notations. They're interchangeable. Okay, they both mean inverse. Okay, arc sine over 2 over 2. A sine of what angle measure is equal to root 2 over 2? Pi over 4. So whenever you see positive, it's easy. If you see positive, it's always first quadrant. But if you see negative, then you have to worry about, okay, is it fourth quadrant or second quadrant? And only sine and tangent is fourth quadrant. Cosine is going to be second quadrant. Okay, so if you see a positive value, it's easy. It's always first quadrant. Yeah, it's always going to be pi values. Yeah, I'm going to ask everything in radian measure. Okay. cosine, inverse cosine of root 3 over 2. In other words, where is cosine of theta equal to root 3 over 2? Pi over 6, right? So if you see a positive value, it's gonna be easier. Everything will just be nice and easy first quadrant. Okay. Where is cosine equal to negative 1/2? Okay, so now we have a negative. Where do we look? Cosine for negative, we look in the second quadrant. Yeah, second quadrant. So where is cosine equal to negative 1/2? 2 pi over 3. All right, where is tangent of theta equal to negative root 3 over 3? We see negative, we see uppercase T, we see principal values. Where we're going to look? Yeah, we're looking at the fourth quadrant, right? So fourth quadrant is y over x. Negative 1 over root 3 is same thing as negative root 3 over 3. It's 11 pi over 6, but we got to make an adjustment. That adjustment is negative pi over 6. Arctangent equal to negative root 3. So we ask ourselves, tangent of what angle measure is equal to negative root 3? Again, we see negative. Tangent is going to be in the fourth quadrant here. So where's negative root 3 going to occur? Yeah, negative pi is right. Instead of saying 5 pi over 3, we got to make an adjustment. We say negative pi over 3. Okay. All right, so our classwork is just page 9. It should go quick. You know, you can finish it within 5-10 minutes, and I'll come around and check you guys off, and we'll be done.
This one, will you give us a circle as well? I get like,
And so if you look at a sine graph, right, your sine graph is only living between the. So we don't get this up. So,
Awesome.
Got it, right, so. Tangent is y over x.
This is a good.
So you want to look, if you want to look for 0, you want to look for where y over x equals 0. 1 over 0 doesn't make sense. Negative 1 over 0 doesn't make sense. 0 over 1, that makes sense. Right. So. 0, yeah. And then for 1. Look for 1 over x squared.
That's the ways of yours.
Okay, so the sign graph is going. That's right. It's always between -1 and 1. It never reaches as high as 30. So that becomes the point.
Smiling.
Guys, let me put this up so you guys can check your answers, but yeah, but keep it out so I can just walk around and check it out.
It's on this kind of street, like. That's the. I was last one with that class.
We choose a little bit disorganized.
Outside.
I feel like my mom went out the conference and like she's so smart and all the stuff is like. We were just learning in progress now. So she was just like, we understood the good stuff. We can knowledge.
Yeah, so sign graph.
Yeah, like I took the same grade.
Yeah.
It's my dad's.
Let's get online.
Yeah.
He has. He wants to have.
I'm not looking for that, so. Yep, so.
Five months.
Did they kind of, did they feel like it's sad?
Yeah. I have no idea. Eat the answer.
Yeah.
Yeah, it's not on my phone.
Oh, Mr. Antley.
Yeah.
That's not ridiculous.
Last year. Like. Sure, that one.
Hi, guys. Yes, you'll make it to the bus.
Long grant on the test. We were like, we like such big. No way.
I've seen.
It's. I got to get it. Yeah, like.